Okay, we're going to look at binomial expansion. So this little equation here is in your log tables on page 20, and it's also in your books. What binomial expansion is about is if we have two terms, first term and a second term in a bracket, and it's all multiplied to the power of something, a real number up here, what's it going to be? So let's take an easy one first of all, x plus y squared. You'd be used to doing that and it looks like x plus y, and you just expand it out because it's the bracket multiplied by itself because it's squared. Then you've gone on, you need to separate it out like so, separating out the first bracket and multiplying it into the second bracket, and you'd get x squared plus xy plus xy plus y squared. Simplifying then, you get x squared plus 2xy plus y squared. So that was fine, that's not too bad. Now when it gets to the point of let's do x plus y to the power of 4, and you say, okay, well, x plus y times x plus y times x plus y times x plus y, and you have to do all of these steps here to get to the final answer. It becomes very time consuming. And you can imagine how much work would be in x plus y to the power of 9 and so on. So this is what the binomial expansion comes in handy for. So we're going to follow along with this formula. But first of all, I'm just going to show you a few things to recognize. So in this one here, x plus y to be squared, we have the first term and we have the second term. So I want you to think of them like that, whatever's inside the bracket, first term and second term. Now if you notice, this is squared, and when it was squared we ended up with 3 terms. Now if I actually show you what x plus y to the power of 4 turns out to be, it turns out to be x to the power of 4 plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus y to the power of 4. And here we have a power of 4 and we end up with 5 terms. So that's helpful when we're actually doing out our binomial expansions. So let's do one. Let's do a question here. So an example, we're going to do a binomial expansion of x plus y to the power of 7. So again, we have our first term here, and then we have our second term here. Now it's to the power of 7, so I'm going to do out 8 spaces. And see from the equation, we've got pluses everywhere. So I'm going to put pluses in between them. Now, up here, we have the number n, which is to the power of, whatever the bracket is to the power of, choose 0. So that's what n choose 0. N choose 1, n choose 2, n choose 3. So the top line are all the values of whatever the power is. So the power in this example is 7. So you're going to do all your brackets. Now this is takes up a lot of space here, so try and be as concise and kind of bring everything together as much as possible. So 7 is in the top of all of the brackets. Okay, and then it starts with 0, 1, 2, 3 at the end. And we're just trying to find a small bit of our coefficient when we're doing this. We're just following the formula. Now, it's the first term. So see how here in this example, x is to the power of 4, and the first term is x to the power of 4. So you're going to take the first term, which is x in this example, and it's to the power of 4. And it works all the way down, x minus 1, x minus 2, n minus 3, so on. So this is going to be x. Sorry. That should be x to the power of 7, because we're timesing it by 7 here. X to the power 6, x to the power 5, x to the power 4, x to the power 3, x to the power 2, x to the power 1. I'm not going to write in 1 because x to the power 1 is x. And then at the last bracket, x to the power 0 is going to get you 1. So I don't need to write that in. Now you come along and you look at your second term. And if you look back up here, the second term is y as well. And the last term is y to the power 4. So you're going to work your way backwards now. Y to the power 7, y to the power 6, y to the power 5, y to the power 4, y to the power 3, 2, y to the power 1. And then y to the power 0 again over here is just 1, so I don't need to put that in. So all you have to do is now put into the calculator 7, choose 0. And that looks like it. Just put in 7. Then there is a little button on your calculator, you should find it, and it looks like on my calculator it looks like NCR, like that. So you're going to press that button and then you're going to press 0, and it comes up as 7, choose 0 on the calculator. And what you're going to get for that one is 1 x to the power 7 plus, put in 7, choose 1 now, you're going to get 7. Follow along with whatever's here. 7, choose 2. And continue on. And that's the binomial expansion done. And then also, if you can see, there's a bit of a pattern. It goes 1, 7, 21, 35, 35, 21, 7, 1. So you know you're kind of on the right track when doing that. So now we're going to look at a slightly harder one. The x's and y's are gone. So we're going to again just have to look at it as the first term in the bracket. And the second term I'll do in purple. Here. So again, we have 6 of them, so we're going to have 7 spaces. Okay, so we're going to put in our brackets first. So the number n goes on top of all of the brackets. And then we start with 0, 1, 2, 3, 4, 5, and 6. There. Okay, so you come along and do your first term then. So remember to put in all of the 2x squared. So it's going to be 2x squared. And then we start, if you remember, with the 6. 2x squared to the 5. 2x squared to the 4. And so on. And I'm just down here, I'm going to write 2x squared to the power 0 is 1, so I don't have to put it in. And then we start at the opposite end, and we're going to do our last term in purple, and we're starting with the highest number. 1, so I don't need to write in 1 there. And then 3 over x to the power of 0, anything to the power of 0 is just 1. So I'm not going to bother writing that in. Now, so there's just a few indices rules to rejog our memory. So I'll write them up here. Anything to the power of 0 gives us 1. Also, if I have two things inside a bracket, x times y to be squared, that can change to x squared and y squared times each other. If I have a scenario where it's x over y to be squared, that turns into x squared over y squared. If I have another scenario where it's a to the power of x to another power, that goes into a to the power of x times y. So for example there, if I have an x squared times a 6, that's going to be x times 2 times 6, which is x to the power of 12. Also then, if I have a to the power of x and a to the power of y, I can work that out to be a to the power of x minus y. So for example, if I had x to the power of 4 over x to the power of 3, that's going to be x to the power of 4 minus 3, x to the power of 1. So there are all your indices rules there. So just want to recap those before we get into it. Okay. So now we need to work out all of these. So first of all, do your choices. So again, 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3, and so on. But I'm just going to lay out the format again. So I had 6 terms, so I'm going to do 7 dashes. Okay, so when you put in 6 choose 0, you're going to get a 1, and then so on. You should get all of these numbers. Okay, so now you're going to start off 2 x squared times the 6. So you're going to look at 2 times 6 first of all. Sorry, 2 to the power of 6 is going to get you 64. And then x squared to the power of 6, you look at the 6 times 2, and that's going to get you x to the power of 12. The next one, 2 to the power of 5 is 32, and then x squared to the power of 5 is x to the power of 10. 2 to the power of 4 is 16, and then x squared to the power of 4 is x to the power of 8. So it's all about just knowing the rules of your indices here. So I'm going to fill in the rest of them. And then the last one, there's nothing there, so we're going to leave it blank. So we're going to go on to our second term now. So I'm going to keep, there's nothing in this section for the second term, so I'm going to leave that blank. So we're moving on to the fourth bit, which is just staying 3 over x. And the next part is 3 squared over x squared. So that's going to turn into 9 over x squared. And then the next one is going to be 27 over x cubed, and so on. Okay, so you're going to take a look then at each section and see what you can simplify down. So that's first one is just going to stay as 64x to the power of 12 plus. Then you're going to look at the, get a different colour here. You're going to look then at the x's and if anything can cancel. So that is reading like 6 times 32x to the power of 10 times 3 all over x. So if I just look at the x's, it's going to be x to the power of 10 over x. So that's all going to change to x to the power of 10 minus 1, which is x to the power of 9. Okay, and then I can just look at the numbers separately. So what's 6 times 32 times 3? Put that into the calculator, and you're going to get 576 x to the power of 9. You do the same then for the next part. Just look at the x's first of all. So it's going to be x to the power of 8 over x to the power of 2. That's going to be x to the power of 8 minus 2, which is x to the power of 6. Then take a look at the numbers. 15 times 16 times 9. And you're going to get 2160 x to the power of 6. Work all your way down through that, doing the exact same thing. And this is what you're going to get for all of them. And that is the binomial expansion done for that one. Now, we are going to look at some questions that can be asked about binomial expansions, and we're going to use this exact example for all of them, seeing that we have all of the terms here and we can double check them. So the first question that you can sometimes be asked is this. So let's say we want to get a specific term. We don't need all of them. We just want a specific term out of that binomial expansion. So let's pretend we didn't do it, first of all. We didn't do the binomial. And we don't want to, we just want to get a specific one. You're looking at this formula here. And this is to do with sequence and series. You're finding a general term for the sequence. And this is how we need to use this to get a specific term. So we're looking for the fourth term. So to see how it says r plus 1 there. So if we're looking for the fourth term, Tn equals T4. I need to change that to T3 plus 1 because R equals 3 there. Okay, so we're going to use R3 for all of this. So we're going to fill in the equation there. So T4 goes to T3 plus 1 equals. Then you follow along. So N is the number up here, which is 6. So 6. Then R we found out to be 3. And then this again is not just x, it's the first term, which is 2x squared. So 2x squared to the power of n minus r. So n in this scenario, again, is the 6. 6 minus the r is 3. And then our second term is 3 over x here, and it's the power of r, which is 3. So you go and put in 6, choose 3 into your calculator, and you'll get 20. And this all changes to 2x squared times 3, or to the power of 3. And this stays as 3 over x to the power of 3. So that becomes 20 times 8x to the power of 6 over 27 over x cubed. All equating to 4,320 x to the cubed. And we're just going to double check now that that is the fourth term. There it is. Okay, so that's the fourth term. Okay, another question that you can be asked is this. So find the term independent of x in the binomial 2x squared plus 3 over x to the power of 6. So if I just flick back to show you what I mean by independent of x. So which term basically doesn't have x? So we see already there's that one there. But let's pretend we don't know and we want to find it out. So we need to fill in as much as we can about this formula. So we need to know this. N we know is 6. We don't know R. x is the first term again, remember? Don't be tempted to just write in x is the first term. 2x squared times 6 minus r. And y is the second term. 3 over x times r, which we don't know. Now, we're just interested in the x part, because the term that's independent of x. So there was no x there at all. So x to the power of 0, if you remember, is 1. So I'm trying to figure out what x value, or what term, is going to give us an x to the power of 0. So I'm just going to subtract or take out, extract, let's say, the powers there. So I have x squared times 6 minus r from this section. And then I also have x is underneath the line, so I'm going to write divide x times r. So if you remember, this section is going to turn into 3 times r to the power of r and x to the power of r. So I've taken this part, which is underneath the line, and this part here, and I've put them together there. So if you work that out, that's going to turn into x to the power of 12 minus 2r over x to the power of r, which is then going to turn into x to the power of 12 minus 2r minus r, which is going to be x to the power of 12 minus 3r on top. So you're only interested in the x values because you want to see which value for r is going to give you an answer for x to the power of 0, because that term will have no x. X to the power of 0 is just going to be 1. So we can let the two top parts, the two indices here, equal each other. 12 minus 3r equals 0. Move everything around to find and isolate r. R equals 4. So, do you remember back here, r plus 1 equals tn, the term, the number of the term. So, if r is 4, then the term that's independent of x is going to be 4 plus 1, which is t5, term 5. So let's go back up here and check it. Term 1, term 2, term 3, term 4, term 5. So that's right. And that's how you do that one. Okay, we have one more to do. So here it is. So find the coefficient, which is the number in front of x, of x to the power of 6 in the binomial expansion 2x squared plus 3 over x to the power of 6. So now instead of looking for which term equals x0, x to the power of 0 like the last one, we're trying to find which term will give us an x to the power of 6. So again, we're just going to write it out as much as we can. We know that n this time is 6, don't know r. X is the first term to the power of 6 minus r. Y is the second term to the power of r. So again, I'm only interested in the powers of x there, so I'm going to take those out. So if there's x squared there, and it's been to the power of 6 minus r. And then underneath the line, there's an x to the r. So again, just this section and this section. And we've already worked that all out to be the following, which is x to the power of 12 minus 3r. And I want to find what term is it equal to x to the power of 6. So again, I'm just going to let the top parts equal each other. Move it around and to isolate r. So I find that r is 2. So remember, r plus 1 equals the number of the term there. So that's going to be 2 plus 1. So it should be term 3 where we get a coefficient. So term 3, you can see that it is x to the power 6 and our coefficient is 2160. So it is term 3. So we're just going to fill it in now using our general part again so we can find the actual coefficient. So again, we found out that r is 2. So I'm filling in 2 for wherever I see r. Again, the first term there is 2x squared times r. Remember now 6 is n, and then r is 2. And then our second term is 3 over x, and then r again is 2. So all of that is then going to equate to our coefficient and the x value, which we'll see is there. And that's it for the binomial expansion.